The one-to-one property of logarithms is stated like this. Log base b of x equals log base b of y. So if you are given this, then this is simply x is equal to y. But here's the catch. There's a couple requirements. The bases have to be the same. Okay, so the bases must be equal. You also can only have one log on each side. You can't have two logs. You can't have log base b of x and log base b of y on the left and then log base b of z on the right side of the equal sign. You can't have one plus in front. It has to be strictly just a log equal to another log, and the bases have to be the same for this to be true. So let's walk through some examples. In example 1, we have one log and only one log on each side, and the bases are both 2. So we can use the one-to-one property. So we can essentially get rid of the logarithms, and we have 7 equals x. In example number 2, we have a single log on the left, but we don't quite have a single log on the right because this 2 is in the way. So you're going to use log properties and fly this 2 so that you have a single log. Log of x squared equals log of 9. So now, using the one-to-one property, we can say, okay, x squared then equals 9. So x is going to equal positive and negative 3. Now, when we solve, you must check your answers. They may not always be true because you can't take a log of a negative number. So, when you check positive 3 and negative 3, you have to check in the very original. Not after you square it down here, right here, this original. So, can I put in plus 2? Yes, I can do plus 3. I can do 2 times log of 3. That's totally fine. But can I plug in this negative 3 and have 2 times the log of negative 3? No, I cannot have a log of a negative number. So your positive 3 is your only answer for this problem. Okay, in number 4, this is where it can get a little bit trickier. We have a single log on the left side, and we have 2 logs on the right side, and we have 2 logs on the left side. So this means that we need to use our log properties and make a single log on the left side. This is where writing as a single log comes into play. So since they are being added, we are going to multiply and have log of 2y equal to log of 9. So now I have a log, both base 10, a single log on the left and a single log on the right. So now I can apply the one-to-one property and say, okay, well 2y equals 9. I'm going to divide by 2, and y equals 9 halves. Plug this in, it works. This is our final answer.